Hello and welcome to this short session about new scenarios that are enabled by Windows 10 for near-field communication, Bluetooth Low Energy, and Bluetooth beacons. I'm Andreas Jackel and I'm working as mobility evangelist for Tieto. You can also follow me on Twitter at @AndyJackel. I'm running the Mobility Builders community where we organize regular mobile developer afterwork events in Vienna. I'm currently a Microsoft MVP for Windows platform development. And before I've been working at various technology companies, always mobile focused, for example, Mobius, an own startup, Nokia in Finland, teaching mobile commuting, and also Siemens BenQ Mobile for augmented reality apps and games. So what are we going to talk about in this session? So it's a quick overview of what's new in Windows 10. This is a special focus. So first of all, I will start with quick intro about near-field communication, then what's new about field communication in Windows 10, that's NFC simulation. Then I'll talk about smart cards and how the smart card support in connection with NFC works in Windows 10. So you now have tag access, which is very important for several scenarios. And you can also do host card emulation, which is really cool. And then the second part will be about Bluetooth Smart or Bluetooth Low Energy, where I'll tell you a little bit more about Bluetooth beacon support and Bluetooth beacon specifications, like what is Apple iBeacon, what is Eddystone by Google, and how can you interact with those formats from your Windows 10 app. So let's start with near-field communication. And especially for near-field communication, first let's take a look at the open NFC format. So the scenarios that don't really require any kind of encryption or any kind of security. So these are the basic scenarios and how you can work with them with Windows. So this has already been working since Windows Phone 8 and also Windows 8. But as we will hear then soon, Windows 10 added a few new features to this part as well. So what is NFC? You've maybe already used it. If you have got an ATM card or a credit card, you can simply hold it to the payment terminal and do the payment without actually having to put the card into the terminal. Or for example, if you have a Bluetooth headset, you just tap it with your phone and you immediately hear the music stream through Bluetooth headset. You can tap a speaker, you can tap a business card to just import the contact to your address book, or you can, for example, share a picture from one phone to the next, and the connection is established if you just tap the two phones together. So about this tapping, what does it mean? NFC is really a short-range wireless technology. So in practice, it actually works up to around 1 centimeters in the antennas in mobile phones. But to make it easier, you just say you tap something with your phone and then it will work. The connection speed is very slow. So we are talking about speeds of around 400 kilobits per second. Note that this is kilobit and not kilobytes. So it's really, really slow. It's just enough for sending a payment confirmation, for example, or sending Bluetooth pairing information or a business card, but you can't transmit the picture itself using NFC. That would just take far too long. Advantage is that it's working instantly. So you just tap something, tap the devices, tap the cash register or something else, and it immediately works. You don't need to enter PIN codes, you don't need to do some pairing, you don't need to wait. So in the ideal case, the data is transferred in a few milliseconds and you're ready to go. That's the really cool thing about NFC. NFC is currently available in most of the mid and higher class Android devices, as well as all the medium and higher class Windows Phone devices. The iPhone by Apple has NFC as well, but it doesn't support the open NFC scenarios. It's not with a public SDK. So what can you do with NFC? One important part of it are NFC tags. NFC tags can be any kind of cards. For example, there's kind of NFC tag in an event badge, maybe in a business card, for example, in a speaker, in a headset, in a passport, in your credit card. What is it essentially? Normally you don't see it because it's hidden, but in reality, as you can see in the upper picture, it's an antenna, and the antenna then gets the power, if you tap it with the phone, through an electromagnetic field of the phone. So really, the tag itself doesn't have any kind of battery. You just tap it with your phone, and the power is kind of transferred to the NFC tag, and it's enough power to power up a microcontroller, a really small one in the NFC tag, which can then talk wirelessly to your phone. So it's really a bidirectional communication. The NFC tag, even though it's just a small card, is actually talking to your phone, and the phone is talking back to the card. And they are exchanging commands and transferring data. How much data can an NFC tag actually store? So it depends, of course, on the tag that you buy. There are different standardized types, but they're all very small. So usually we are talking about tag sizes from 48 bytes up to a few kilobytes. So you can't really store a video on an NFC tag, but it's enough for example, a web address. So you can tap the NFC tag on a bus station and you will immediately see the schedule from a web address without having to type in something or without having to scan a QR code. Most of those scenarios thankfully work cross-platform. So they work no matter if you have an Android phone or Windows phone or a BlackBerry device or something else. And this is thanks to the standardization of the NFC forum. And the NFC forum standardized protocol specification, which is called NDEF, which is short for NFC Data Exchange Format. What does it describe? It describes how the content is formatted on NFC tags, or how the content is formatted if you tap two phones together, what they exchange. So it's really the content specification, not the physical or the radio layer. And what does it specify? It specifies that there is an NDEF message, which is kind of a container, and the NDEF message can contain one or more NDEF records. An NDEF record can, for example, be a URL, a web address, and then if you tap the tag, the phone will read the NDEF message, contains a single NDEF record, and the NDEF record then contains a URL. The phone will then ask you, do you want to open the URL? Okay, and it immediately opens in your web browser. So NDEF is the data container for structured data. It doesn't define how the data is actually transmitted, but it defines the data itself. There are several different categories. For example, you can have URLs, you can have text messages. URL can also be you tap something and SMS is sent, which is often used, for example, for buying public transport tickets. You just tap the NFC tag at the bus station. The phone will ask you, do you want to buy a ticket? By sending this SMS, you just confirm, and that's it. You get the ticket to your phone without having to type in some SMS yourself. There are also MIME tags, for example, for storing an image or a business card. I said image is maybe a bit tricky for NFC tags, but for transferring, if it's a small image, it's maybe still working, or business cards. Also important is the handover tag, which is handing over from NFC to another carrier. This is used, for example, if you tap a Bluetooth speaker so that you can listen to music. You just tap it. By NFC, the two devices exchange the Bluetooth pairing information, and then they do the pairing themselves. It saves you from having to making the device visible, entering PIN codes, doing the pairing manually. So it just works by tapping the devices, and they do the handover themselves. All of those formats are a bit complex because you really have to optimize those, make them fit on this really, really tight space. And Windows actually supports some of those types out of the box, but not everything of it. For the other types, I've created an open source NDEF library, download from GitHub for free. It's all under an open source license, the LGPL license, which allows you to actually use it also in commercial projects without having to open your own source code. It's fully documented, and it allows you, first of all, to create those NDEF records and messages according to the standards, and also to pass information if you read or get some NDEF message so that you can convert it to kind of human readable information. So how does it work to read from an NDEF tag or to get a message? So first of all, in Windows, And as I said, this also already worked in Windows Phone 8 and Windows 8, but it still, of course, works with the same API in Windows 10. So first of all, you activate the proximity device. Saying proximity device get default. Usually there is only one NFC device, so it's okay. Of course, there could be more, then you would just say, give me the list of all NFC devices and pick whichever the user wants to have. Second step is that you subscribe to all NF formatted tags so that you get a callback every time the device taps a tag or the device, for example, taps some other device. And you would then get a callback to the message received handler whenever there's a message transmitted to your device. In this callback handler, the message received handler, you will get information about the sender, which you can usually ignore, and the message itself that was transmitted to your device. This message is what you need to take a look at. So in the first line, I will just I'll get the data out of it, convert it to a byte array so that it's a bit easier to work with it. Then I use this endf message class from the C endf library, which can convert the byte array to some useful class, which is the endf message. And as said before, the endf message contains multiple endf records. Could be one, could be more of them. So we just loop over it using a for each loop, and then we can check the specialized type. For example, is this record a UI record? If yes, we can cast it to this specific class and conveniently access the UI contained in the record. And of course, there are many more specialized classes, for example, for a telephone tag, for an SMS tag, for a Bluetooth handover tag, so you don't really have to worry about how all the bits and bytes are encoded. You just check, is it a Bluetooth handover tag? And then you get immediately the Bluetooth address and everything else out of it. So I said all of this already worked in Windows 8 and Windows Phone 8. What's new in Windows 10 and which is really, really useful is that the emulator can now also simulate NFC. Because before, it was actually better to have a real NFC device to test. There was some kind of unofficial tool to simulate it a little bit, but now it's all official and built into the emulator. So you can just, you can see here, also enable discovery of peer devices. You can send different endf messages to the devices, and you also see the messages that have been received or sent in the window at the bottom. Really, really useful and new in Windows 10. So this proximity API, it's easy to use, very simple, especially with the endf library. It's also quite powerful. However, it can only work with open tags. So with Windows 10 and also Windows Phone 8.1, it's actually possible to do write protection, but those tags are then readable by everyone. You can't really tell your Windows device to encrypt the tags or send some specific decryption key so that you read encrypted messages. So this all doesn't work with the proximity API. Use cases are, for example, NFC tags that have a URL on a product. So this is kind of similar to how a QR code works, just with the advantage that an NFC tag doesn't need to be visible, not this kind of ugly white and black pattern. It's just invisible. For example, it can be very small in a Bluetooth headset. You just open it and it opens URL. Also very important is Bluetooth pairing in accessories like speakers or headsets, or connection handover. So if you tap two phones together, they can transfer a picture using the Bluetooth or Wi-Fi direct. So they just do this whole handling of which connection to actually use for sending the picture or video using NFC, and you don't have to worry about establishing a Bluetooth or Wi-Fi direct connection between the two devices. So this was the open NFC part. Let's take a look at a bit more lower level NFC interaction, and this is new in Windows 10. So you can now also work with smart cards. So what is a smart card? Essentially, a smart card is something that's like your ATM card, your credit card. These are smart cards. So they can either work with an interface that's using contact. So you have a chip included, and you put it into the reader and it will communicate over the chip. The other alternative is to have a contactless interface to the smart card, which can of course then be NFC compatible. So, for example, with Maestro PayPass, you just tap the NFC card, reader terminal, and it's pretty much the same communication as if you would put it into the reader. It's just now using the wireless NFC carrier to transmit the data. So the smart card content, so it can actually be very powerful. There's a real microprocessor inside the smart card, which is usually a lot more powerful than the one of simple NFC tags. It also has non-volatile memory, so you can store data, to store a lot more data than on simple NFC tags. They usually support cryptography and highly secured hardware encrypted data. And you can actually also put real apps on the smart cards. Depending on the operating system, so many of those, for example, use Java card operating system, where you can really write your own apps that run on those smart cards. Use cases are, for example, credit cards, public transport cards, key cards for doors. So all those kind of things where you actually need really, really good security. This is then done using a smart card. So in Windows Phone, Windows phones starting with the Lumia 830 and 730, now then also the Lumia 640, Lumia 950, for example, and all upcoming Lumias, they have a new NFC chip, which is the NXP PN547. And starting with this NFC chip, the Windows devices also support the smart card communication over NFC, so that you can actually talk to, for example, your ATM card just by tapping it with your phone, and you can do all the interactions, or like with your key card or whatever. So this is really, really important. New feature of Windows Phone 8.1 actually, starting with this one, and especially then 10, so that you can also use the more secure scenarios with NFC tags with smart cards. So how does it work? Want to read a smart card, first of all, you should check does the device actually support smart card reading. You can just ask Windows Foundation metadata API information if this specific type is present, which is the smart card connection. If it returns true, then you can use it. If it returns false, so there's this exclamation mark here, then you know this version of Windows doesn't support NFC card reading using the smart card API. If you then know that it's supported, you just find the device and subscribe to it. So it's rather similar to before. So from the smart card reader, you just get, first of all, actually device selector. So you say which specific interface do you like. In this case, we, for example, specify we want to have a smart card reader that works using NFC. Then you ask it, please give me all the smart card readers in the device that support NFC, which is, of course, usually one. And then you just, from the ID that you get back, in this case, we just use the first one. Could be more, but usually, as I said, it's just one. You just establish a connection to it and register for a callback whenever the smart card reader finds a card. You want to get a callback to this smart card reader on card edit method. In this callback function, you receive two arguments similar to the NFC proximity case. First of all, the reader that actually sent you the message, and in the second parameter, the actual data that was sent to you, or the kind of connection to the card in this case. So, and you can just exchange any kind of data you like with the smart card. Now the connection is established. For example, you can send a command that is called answer to reset, or ATR, which is according to ISO 7816, which is one of those standards that most of the smart cards adhere to. You just send this message, and then actually the answer of the smart card will be some basic information about the smart card characteristics, behaviors, in which state it is currently in. Just learn a lot more about which card is the user actually tapping with his phone. And in the next step, you can connect to the card if it's the one that you're looking for, and then send commands to the card and data that the card returns to you. So how does this transfer actually work? This is done using APDUs. APDU is an application protocol data unit. This is the communication protocol that you are using for smart cards. On the left side, we've got a Windows Phone device. On the right side, we've got a smart card with the antenna, which is for the wireless NFC interface. And when you tap it, you establish a connection, for example. You send a command APDU, which has a header, contains instruction codes, so what to actually do, which command to trigger, and some data with it. For example, if you want to read specific data from the smart card, you say, which memory area of the smart card do you want to read? The card will process your command, will check are you actually authorized to do it, and then send a response APDU to your phone, which is a status code, and response data. For example, the memory area that you just wanted to read in case you're allowed to do so. So for sending those smart card commands, it's a very, very low level thingy. So it's really sending bits and bytes from your device to the smart card and vice versa. So there is a library from Microsoft, which is the PCSC library, and which is now actually included in the Windows 10 NFC sample, which you can download from GitHub. So this is one of the official Microsoft samples, and this one really shows some interactions that you can do with smart cards to read some more data out of it. So the example detects the smart card type, and then it also contains some of the most common commands, for example, to authenticate with MyFair NFC cards, which is one of the most common NFC standards in the world for like those ticketing scenarios, transport scenarios. These are usually MyFair based, which is also an NFC standard. And then you can just transmit data and authorize for the MyFair cards. What is especially new in Windows 10 is the transparent exchange mode, which allows you to send custom commands to those smart cards. So those standard commands, like the standard MyFair commands that worked before, but now you can actually send any kind of command to an NFC card or to a smart card. So these could be manufacturer-specific commands. For example, there are several new commands for specific NFC tags by NXP in the NTAG 216, and you know those commands, you can send those APDU commands to an NFC tag, and you will be able to use this additional manufacturer-specific functionality, which is outside of the common standard. You can, of course, also interact with custom cards, or essentially you just have raw tag access. So one example of those is MyFair Ultralight C. This is one of the most common NFC formats and tags. What's the reason for it? It's actually because it's very cheap. So a MyFair Ultralight C tag is very, very cheap to get. And this is why they are so common. And the C in the name actually stands for cryptography. So even though it's just a very cheap NFC tag, they actually support at least a little bit of cryptography. So it's not a full-blown smart card. It's not same level as your credit card, but it does work. And how does it work? So we can, for example, then add something to the Microsoft NFC example. We just write this custom command, which you can see here, and send it to the device using this MyFair Ultralight Access class, or instance, which is from the sample. So the write command, according to MyFair specification, is A2 in hexadecimal. Then 8 is the page address, so we actually want to store something to the memory of the NFC tag at the address 8. And memory that we want to write is ABCD. So these are 4 bytes of memory that we want to store to the NFC tag using this new transparent exchange mode, using really raw MyFair communication protocols. And then if I execute it, so this is now using Windows 10 mobile SKU, execute it, you tap the NFC tag, and then you actually see that from block 8 to block 11, so it's always bigger blocks. We have actually written A, B, C, D, so the first 4 bytes of this memory to the MyFair Ultralight C tag. So the rest of this example is coming from Microsoft, so it will tell you all this other stuff. So it will just tell you this is a MyFair Ultralight C tag. If you tap it, it will read the memory, but we just now added one command to this example, which actually modifies the memory using one of those specific MyFair commands. They have raw tag access and raw memory access. Okay, so next part is about host card emulation. And this essentially allows you to have a virtual smart card that you create with your app. This is also new in Windows 10. It has also been recently added to Android and is one of the most important things of NFC nowadays, because it actually really allows you to use your phone as a credit card. So then the phone actually acts like it would be a credit card. You just hold it to the reader in the shop and you can immediately pay with your phone, which is really cool. So as said, you simulate a smart card with an app. It has actually already been supported by Windows before, so before Windows 10, but only using SIM cards. So if your SIM card from your mobile operator supported card emulation, you have been able to use it, but in reality, the situation is just that hardly any operator added support for having a wallet using the SIM card on a Windows phone. And now with Windows 10, you don't actually need a SIM card anymore. You can just create a smart card, a virtual smart card inside of your app, and you can directly communicate with the NFC reader and the NFC device. So how does it work? You can, for example, register for a specific applet ID, and then when you tap the reader, it will automatically launch your app. For example, a loyalty card in your favorite coffee shop. You just hold the phone to the reader. It will immediately open your loyalty card app and then give you the points or maybe even pay with it. In Windows 10, there's now the difference between payment and loyalty. So for payment, you can only have one single default app. So if you go to the phone settings in Windows 10 Mobile, you can enable Tap to Pay, and then you can select a default payment app. And whenever you tap some terminal which wants to trigger payment, it will always launch this one single payment app. For loyalty cards, you can have multiple apps. So for example, you can have one loyalty app for your public transport service, you can have one loyalty app for your coffee shop, and if you then tap the reader in the coffee shop, it will open your loyalty card app for the coffee shop and you will get your points. And which app selected depends just on the command, this apdu command that the reader sends to your phone, which is just select the ID, which is select applet ID, and then the correct app will launch on your device. So this is all new in Windows 10. And how does it work to actually use it? Of course, first of all, you have to check for API support. So it does require new hardware. It does require phone to have NFC if you want to use it via NFC, of course. So first of all, you have to check, is the API supported on this device at all? This is the smart card emulator, Windows device, the smart card namespace. In the second step, you check if this device actually supports emulate smart cards as well. So you just get the default device again. If it returns some device, you know it's working. If there's no device here, then you know, well, apparently this phone supports the API, but it doesn't have a smart card device included or attached. And then the third step to check is to check for host card emulation support. So from the smart card emulator, you can just say, is host card emulation supported? If it's true, then you know that you can now really use host card emulation on this phone. For setting it up, it works like this, that you have, first of all, a list of applet IDs. So just say, I have a name I call my applet ID, And then in this smart card applet ID group, you just specify this my loyalty card with the ID, and this ID is used by the reader to actually launch your app. You can specify the smart card emulation category if it's payment or other, and it's a host, and then you just register your applet using the system so that the phone will know when it gets the command to actually launch your app from the outside by tapping the terminal. The terminal will say, I want to launch this applet ID, and the phone will know that it has to launch your app. And yeah, to actually make it really work, of course, you should have a background task as well, so that you can immediately process the interaction without actually having to start a whole app, which maybe takes too long, really quick. So you should register a background task as well. And for the background task, you say I want to have a trigger, which is a smart card trigger. So every time the emulator host application is activated, every time you tap the loyalty terminal in your shop, I want to execute my background task. And you can do the transaction, and of course you can still launch your app from the background task. The actual interaction with the terminal is done really quick in the background task, and then afterwards you start the app and say, thank you for shopping, you have just bought this cafe latte and you earned 200 points for it. So it's still possible, but the interaction itself is then done in the background task. So how does this actually work, the host card emulation implementation in the background task using a smart card trigger? So first of all, this command terminal sends an APDU, which is a typed event, together with some arguments, the smart card emulator APDU received event arguments, which will tell your app a little bit more of what it should do. And then you process the request in the background task, and you use the method called try respond async, where you just send an APDU back to the reader. It can of course go on, so you can send multiple commands back and forth. Usually there will be some kind of, first of all, checking is the app here, then you will some scheme, and then actually will trigger the actual data transfer, for example, for booking loyalty points. And as said, optionally, you can also launch an app which contains the confirmation, or if it's needed, some kind of user interaction. For example, if it's a payment, you might want to launch the payment app and ask the user for confirmation, do you really want to pay 20 bucks for this coffee? So this is also possible. If your app is already running in the foreground, it gets the events as well, even for payments if it's not the default app. So the payment default app is launched if the phone is, for example, in the start menu, but if you manage to convince the customer to open your app before he pays, you can actually also do payments from your app, just loyalty cards. Cool thing is that also host card emulation is supported in the emulator. So on the top left, you can switch to the host card emulation mode and then also generate scripts, because I said it's usually multiple commands that you send back and forth, and you can just test how your app works using host card emulation. So for example, you see that there will be this select applet ID command, which selects your name and your app, and then you get some options and read commands, for example, for requesting payment data. So just a back and forth between your app and terminal. And the terminal you can just simulate using this new functionality of the Windows 10 data. So of course, the whole host card emulation is a really complex topic. A lot of details about what you have to be aware of, especially for payment apps, but also for loyalty apps, how to launch the app, how to best handle it. There is actually a really good blog entry by the Microsoft NFC team blog. So if you're interested in host card emulation, I would recommend this one as a starting point to learn more about host card emulation support in Windows 10. Now let's start with the second part about Bluetooth and beacons. Bluetooth Smart, it's often called Bluetooth Low Energy or Bluetooth LE. In reality, according to the standard, it's actually Bluetooth Smart, and it's part of the Bluetooth standards since version 4.0. Bluetooth Smart is kind of an extension to Bluetooth. It's not backwards compatible, so if you are using Bluetooth Smart to transmit data, a Bluetooth 1.0, Bluetooth 2.0 device can't actually read it. It's supported starting with Windows Phone 8.1 Plus. However, what Windows Phone 8.1 didn't support was Bluetooth beacons. So what's a Bluetooth beacon? For example, an iBeacon. A Bluetooth beacon is essentially just a small microcontroller, a Bluetooth antenna, and a battery. And it's really simple and usually quite stupid thing. It just advertises a message in regular intervals. For example, every 100 milliseconds, it sends out a message via Bluetooth Smart. There's no pairing required or even possible usually, so it's just sending the information no matter if somebody is listening or not. There's also no back communication channel, so you can't actually interact with the Bluetooth beacon and send commands back. It's really just like a lighthouse. It just regularly sends out data and you just receive it or not using your device. So what kind of data does a Bluetooth beacon send? Well, in the simplest case, it's just an ID so that you can identify the beacon and trigger an action because you know that you're close to the Bluetooth beacon, and then you can, for example, launch the app. Or you can know that you are in a shop close to this special offer, and you can just shop app say, you're just looking at this offer, maybe you want to recommend it to your friends, for example. This specific feature is only supported in Windows 10. So what's the difference? Windows Phone 8.1 and Windows 8.1, they of course did support Bluetooth and also Bluetooth Smart, but only if you pair to a device. So for example, if you pair to a headphone, you can of course use it to transmit data. If you pair to a second device, you can transmit data to the other Bluetooth device. But Windows 8.1 didn't yet support actually getting data without pairing first. Now Windows 10 enabled this use case, so you can just listen to Bluetooth beacon advertisements without having to pair to the Bluetooth beacon beforehand, which is actually not possible usually. And Windows 10 now supports to discover Bluetooth beacons and also to advertise like a Bluetooth beacon. So essentially you can make your Windows device act like a Bluetooth beacon. So that you as an app send out Bluetooth beacon advertisements for other devices to discover you. So it works like this. There is a publisher and a watcher. So the publisher can send out a payload using Bluetooth low energy, and the watcher can register a filter, what kind of advertisements he wants to get. And every time he finds a payload that matches the filter, you will get an event callback. Let's take a look first at the publishing and then at receiving Bluetooth beacon advertisements. So actually publishing a Bluetooth beacon, it's really useful for testing and for developing your solutions and maybe for more interactive scenarios. In most common use cases today, you just have real hardware Bluetooth beacons placed in your environment and you just listen to them. But I say in many scenarios, it's useful to publish as well. So first of all, you just create publisher, Bluetooth LE advertisement publisher. The second step, you set up what to publish. So you just define kind of which IDs you want to publish, some manufacturer data. So for example, your company ID, which is actually standardized by the Bluetooth SIG. So this is one of those unassigned values. If you would be, for example, Apple, you would have a specific ID to put there, and you just write some data to it. And then, you just say, start publishing this message, and that's it. Your Windows device will now start publishing this message using Bluetooth Smart. Really simple and quick and easy. For receiving Bluetooth beacon advertisements, it's actually pretty much the same code. So I just switched now to the next slide. You didn't really see any kind of difference. What's different is actually just the very first line of publisher. It's now a Bluetooth low energy advertisement watcher. These lines are exactly the same code. So you filter, for example, that you only want to receive advertisements from this company ID using this payload. And then whenever there's a watcher received event, you want to have a callback, and you just start watching for Bluetooth beacons. Almost the same as publishing, it's just kind of the other way around. You just filter what kind of beacons you want to get. So of course, you want to have usually background tasks, because this should also work when your app is not in the foreground. So you can scan for beacons in the background task. And essentially, you just need a Bluetooth low energy advertisement watcher trigger, which triggers your background task whenever there's a beacon found. You can only define one payload filter for energy reasons, and there's also minimum sampling interval for energy efficiency reasons, so you only get one event per second per beacon if you're running in the background. If your app is in the foreground, there are no restrictions. You can get all of the advertisements, even if there are 100 Bluetooth advertisements received by your phone per second, you get all of them. But if your app is running in the background, using a background task, it's a bit limited, so that the phone battery is just saved. And for making this more efficient for the hardware battery, it actually also requires new hardware, which is called a hardware offloading feature, so that actually the Bluetooth watching is done completely in hardware and the app doesn't have to run all the time, which would, of course, kill your battery in a matter of a few hours. So all the new Windows 10 mobile devices which do support Windows 10 and Bluetooth will have support for it, according to Microsoft. Also, the previous flagship phones with Windows Phone 8.1 will support it after the Windows 10 update, and also the Surface Pro 3 supports it. And of course, you can also publish beacons in the background. So this works as well. So I've been talking a bit now about beacons, how they work, but how is this data actually structured that you want to send out, that you want to receive? So there's the Apple iBeacon, there's a smart beacon specification called Eddystone from Google. There are others like old beacons. So how do they work and how do they integrate with Windows so that you can actually work with environments that are out there that also work with Android and iOS devices? So let's take a look at those beacon formats. Actually, Bluetooth beacon is standardized. So the way our beacon sends out it's here, it's just a normal Bluetooth advertisement. It's just like your heart rate monitor would say, oh, I'm here, I'm ready to pair. Or your speaker could send out, I'm the speaker, I'm waiting for you. Also, the beacons send out a Bluetooth advertisement. And how this advertisement is sent out is actually standardized by the Bluetooth core specifications. So it's how the communication works. But the thing is, what's not standardized, at least not yet, is what is sent out. So the actually usage data is not standardized, which led to various different specifications. So pretty much the first one was Apple with the iBeacon specification. Then came others like AllBeacon, which is an open specification. And recently also Google released an open source specification for Bluetooth beacon advertisements, which is called Eddystone. So what's the difference between iBeacon and Eddystone, and well, what can they do for you? So essentially the iBeacon by Apple, the beacon sends out three numbers. First of all, the UUID, and then the major and the minor ID. So just a few numbers which are enough for your app to register for a number. So you can just say this UUID, major and minor ID, is mine. And then when the phone finds the advertisement, it will know to launch your application, or even actually tell you on the lock screen there's a beacon nearby. There would be an application in the store for you which could handle and offer you something for this beacon. Do you want to download it from the store? So it's pretty cool. Only problem is that the specification is actually proprietary. It's not much data that's transmitted, it's just 3 numbers, but the license of Apple actually made it so that creating this beacon, following the specification, well, you have to read the Apple developer agreement to know the exact license terms, but it's not an open specification, which is allowed to use by everyone like they want. A bit different is the Eddystone specification, which is released by Google. It's an open source specification released under the Apache license, and it is pretty similar, but more powerful actually than the iBeacon specification, because according to the current state, it allows to transmit 3 different frames. So the first one is the beacon Eddystone UID, which is pretty similar to what the iBeacon can do. So it will send an ID as well, and also the power level. So how strong is the signal that the Bluetooth beacon sends out, which is important for you to measure the distance that you have to the beacon, because the phone will actually also tell you how strong was the signal that you received, and if you know how strong the signal was when it was sent, you can actually find out how far are you away from the beacon. Of course, the more power you have in the beacon, the stronger it transmits, the farther it goes, maybe up to 100 meter, but the more power it will use. So it depends on many different factors, like the battery size, the transmission power, how often you send out advertisements. A beacon battery can last like from 1 month to up to half a year. Cool thing about Eddystone is that it supports 2 additional frame types. One of those is the telemetry frame, which sends out information about the battery state, so that you know how full the battery still is, the temperature, and also a counter of how many frames have already been sent out and how long the beacon has already been running since its last power up sequence. The third frame, which is really interesting as well, is the Eddystone URL frame, which just transmits a web address, URL, and also the power level. And the cool thing is that, well, this is actually something that's called the physical web by Google, because it's not connected to apps. So an iBeacon only makes sense if you have an app that can handle the IDs. So the IDs themselves don't have any kind of usable information, it's just numbers. But the URL, it just works with any device without apps. Just go, for example, to a museum or to some kind of statue. It sends out an Eddystone URL frame, and the phone will just tell you, okay, there's this URL nearby. It gives you more information about the statue, and you just open it in the browser, and that's it. You don't need to go to the App Store, download an app, get information. It's just instant. It works on any device, also without the apps, which is really, really useful and makes it a lot easier in the use cases. So back to Windows. So these were 2 specifications released by Apple and Google. Thing is that Microsoft didn't actually release its own beacon specification, so they just released, as you saw on the previous slides, really the low-level tools so that you can work with any kind of beacons. So you just get the byte arrays, and that's it. The rest is up to you. Which is, of course, a bit complicated, because if you go to the Eddystone specification, you will see those 3 frame types. They are, of course, very efficient, also to make the advertisements as short as possible. So there's a lot of bit and byte encoding involved. And it will take you several hours to implement the Eddystone specification on a Windows device, because Google has obviously only released it for Android and iOS, but not for Windows. And also for iBeacons, well, you would need to look it up anyway in the web, how it's formatted, but you also need to find out how to work with it. And for this reason, I've created also a universal beacon library for Windows 10, which is also released under an open source license, fully documented. Also comes with a complete Windows 10 example app, which saves you from all this work. So essentially, you just send every advertisement that you get from your device to this beacon library, and it will take care of the rest. So first of all, it will assign the received frames to individual beacons. because if you have several beacons in your surroundings, all of them transmit all the time, you need to match this advertisement was from the first beacon, the other advertisement was from the second beacon, and then the first beacon sends again. So you need to always match the frames to the beacons, the physical beacons that are actually around you. And the second thing the library can do for you is to actually parse, and it can also create the beacon frames so that you don't need to implement the Eddystone specification yourself. So it will, if you receive an Eddystone frame, you just conveniently get the battery power out of it without having to do all the bit and byte stuff. So an example how to work with this universal beacon library. First of all, you initialize beacon scanning. So this beacon manager is coming from the library. The other 3 lines are exactly the same as we saw before. It's just for starting the Bluetooth low energy advertisement watcher. So you just want to receive all the Bluetooth beacon advertisements around you. And then in the callback, which is also the same as before, what you just need to do is that you send this beacon advertisement to the beacon manager, and the beacon manager will take care of the rest itself. In this case, this is actually coming from the open source example app. It's done in an thread using on the UI thread using the dispatcher, so that you can immediately bind it to the user interface and show the information. Of course, if you only need to store the data, you don't need to go back to the UI thread, because of course this callback is done in the background thread. So if you want to directly show the beacon advertisement data on the user interface, you need to go back to the user interface thread, which is done by this line. So then the beacon library will take care of the rest, and afterwards you can just take a look at the Bluetooth beacons that have been found so far and all the advertisements. So the beacon manager has a list of Bluetooth beacons. You just loop over it using this for each loop, and then for each beacon you can get some kind of basic information, like for example the Bluetooth address or the beacon type, which one it is, and then the beacon can have one or more frames attached to it. For example, the Eddystone can have the UID, telemetry, and URL. You can just check, is this beacon frame now a UID Eddystone frame? If it is, you can just get the namespace ID and the instance ID out of it. Or for example, the transmission power. And all of those things you don't have to parse yourself. It's just working out of the box, the complete Eddystone specification. Because the iBeacon specification is not open, the library doesn't really include how to parse those 3 numbers out of it. But if you take a look at the library, if you search the web, you will easily be able to extend the library so that it also supports iBeacons. Testing this, I've also released this open source example application called Bluetooth Beacon Interactor. Downloading for Windows 10, works on both Windows 10 mobile phones as well as PCs, so tablets and laptops and PCs, of course, if they have Bluetooth smart support. Yeah, what it does, it's really useful for developers. It's actually the very first Bluetooth beacon scanner in the world for Windows 10. It just shows you information about the beacons around you. So for example, in the screenshot, you can see there's an Eddystone beacon, has this address, signal strength, when was the last advertisement received, and then the 3 different frames sent out by the beacon. So some IDs, telemetry, for example, the temperature was 28 degrees, and the UL is pointing to theater.at. The library actually also detects the iBeacons, so you get the same information, address, signal strength, and when it was last updated. It's just that the payload is not passed by the library. You would just have to look up how to get the 3 ID numbers out of this payload. But it's quite easy to do. So let's get to the summary of the short information session about new Windows 10 scenarios. So first of all, I talked a bit about OpenNFC, what you can do using this NDEF protocol for sending and receiving data, for example, from a Bluetooth headset. And what's new in Windows 10 is that you can now also simulate this NFC communication directly from the emulator. The second new thing is the smart card transparent exchange. So essentially, you can now really send any kind of raw and custom commands to smart cards, which means that your app can now talk to transport cards, your app can talk to encrypted cards, your app can talk to passports, ATM cards, whatever you like. It's now all possible. The third new thing is host card emulation, which allows your phone to be a virtual smart card. For example, you can use it to simulate a credit card to do payments directly from your app, and also to do loyalty cards or transport tickets from your app, for example, for your coffee shop, so that you hold the card to the reader terminal in the shop, and the customer immediately gets some points from your application. And the fourth thing that we took a look at, Bluetooth beacons. So Bluetooth has of course been supported in Windows all the time, but now 10 added support for actually receiving data from Bluetooth beacons without pairing first to the beacons. So you can just get the data, and then using the universal Bluetooth library that I've released, you can actually directly work with Eddystone from Google and iBeacons from Apple, and really integrate your Windows app to the ecosystem that you already find out there for Android and iOS. So that's it. Thank you for listening to this short info session. If you want to get more information, if you have any kind of questions, please just contact me. For example, over Twitter, follow me at @andejackel, and I would be happy to hear from you and to support you. Thank you.